All right, today we're going to pull back the curtain on something incredible. We're going from a literal mountain all the way down to the microchip in your phone. We're talking about the hidden world of mineral processing. Let's dive in.
Seriously, have you ever really stopped to think about it? The foundation of our entire modern world. The phone you're holding, the car you drive, the building you're in, it all starts with a rock. But how in the world do we get from a plain old rock to the materials we actually use? Well, that's exactly what we're going to unpack.
So here's the game plan. First, we'll get the basic definitions down. Then we'll get into the really cool part, the heavy machinery that makes big rocks small. After that, we'll look at the clever chemistry used to sort the treasure from the trash, how they polish up the final product, and then we'll tie it all together to see why this whole massive process matters so much.
Okay, first things first. Before we can get into the how, we need to be super clear on the what. We've got to get three key terms straight in our heads: mineral, rock, and ore. They might sound similar, but in this world, they are totally different things.
Okay, so think of it like this. A mineral, that's a pure natural chemical, something like quartz. Now, a rock is just a bunch of different minerals all jumbled together, like granite. But here's the most important one for us: ore. An ore is a special kind of rock. It's a rock that has enough valuable minerals inside it to actually make it worth the money to dig it up. So mineral processing, it's really the art of taking that ore and pulling out the good stuff.
All right, so the very first thing you have to do is an act of just pure brute force. You got to take these gigantic boulders, I'm talking sometimes the size of a small house, and start the process of making them smaller. And not just a little smaller, way, way smaller.
But why? Why all this smashing and grinding? Well, it's not just for fun. There's a very specific target called the liberation size. That's the magic point where you've broken the rock down so much that the tiny individual crystals of the valuable mineral are finally broken free, or liberated, from all the worthless rock that's holding them hostage. You can't sort them until they're free.
And this doesn't happen all at once. It's a journey in 3 stages. First, you've got primary crushing, where these giant machines, basically like huge mechanical nutcrackers, just demolish those house-sized boulders. Then, secondary crushers take those smaller chunks and turn them into gravel. And for the final step, huge rotating grinding mills take that gravel and tumble it into a fine powder, almost like flour, finally unlocking those precious minerals.
Now, for that first big crush, you've pretty much got 2 main workhorses. The most common is the jaw crusher. It's powerful, effective, does the job. But when you need to process on a truly epic scale, like more than 1,200 tons an hour, you bring in the absolute monster, the gyratory crusher.
And just to give you a sense of the scale here, the rocks that are getting fed into these machines can be over a meter. That's more than 3 feet across. We are starting on a truly monumental level. And after all that crushing, all that grinding, what's the final target? About 100 microns. For perspective, that is finer than a single grain of sand. Just think about that for a second. We go from a boulder bigger than you to a particle you can barely even see.
Okay, so mission accomplished. We've liberated all the tiny mineral particles. But now we've got a brand new problem. We have a giant pile of dust that's a mix of the valuable treasure and all the worthless trash. How on earth do you separate that? This is where things get really clever.
Now, there are a bunch of ways to do this, but 2 of the coolest methods are gravity separation and froth flotation. Gravity separation is exactly what it sounds like. It's basically just like panning for gold. You use water, and the heavier, valuable particles sink to the bottom while the lighter junk gets washed away. Simple. Froth flotation, though, that's like something out of a science fiction movie. It's like giving the minerals a bubble bath, where the bubbles are chemically engineered to only grab the good stuff and float it to the top.
A selective bubble bath for minerals, right? It sounds almost too strange to be true. So let's zoom in a little and see how this amazing process, froth flotation, actually pulls it off.
So here's the magic trick. It all starts with chemistry. They add special chemicals to the wet, powdery mix, and these chemicals are designed to attach only to the valuable mineral particles. And what do? They make those particles hate water. They become hydrophobic. Then, they pump air through the whole tank, creating tons of bubbles. Because our valuable little particles now can't stand being in the water, they desperately grab onto the air bubbles for a ride to the surface. The mineral-rich froth gets skimmed off the top, while the worthless rock, which still loves water, just stays at the bottom. It's genius.
We're in the home stretch now. We've successfully separated our treasure, but it's currently in this wet, soupy, frothy mess. You can't exactly ship that to a factory. So we need to do one last thing: polish the final product, and get all that water out.
This final upgrade is all about drying. First, they let gravity do some of the work. The slurry sits in these huge tanks called thickeners, and the solids just settle to the bottom. After that, powerful filters, using either vacuum or pressure, literally squeeze out most of the water. And for the final touch, industrial dryers use heat to evaporate any last bit of moisture, leaving behind a perfectly dry, highly valuable powder.
So, at the very end of this whole long journey, you're left with two things. You have the concentrate, that's our pure, valuable final product, ready to be sold and shipped. And you have the tailings. That's all the leftover waste rock and water that has to be managed safely.
Okay, so we've followed the journey from a giant boulder all the way down to a fine, pure powder. But, so what? Why go through all of this incredible effort? Well, let's connect all of this heavy industry right back to your world.
I mean, just look around you. The concrete and asphalt in our roads, the copper and silica inside our electronics, the minerals in the batteries that power our lives, the steel that makes up our cars, our ships, our buildings. Literally everything we see and use started this way. Without mineral processing, modern life as we know it would just stop.
But all of this, it comes at a price. And a huge part of that price is energy. Remember that grinding stage, turning gravel into flour? It is incredibly power hungry. In fact, for most of these operations, energy alone can be more than half of their total operating cost. It is by far the single biggest expense.
And that brings us to the big final question. You know, the basic ideas here, crushing and sorting, they're ancient. But our demand for all this stuff is growing exponentially, while the easy-to-get, high-quality ores are getting harder and harder to find. So the challenge we're facing is huge. How do we innovate these incredibly energy-intensive processes to make them sustainable for the future? That's the puzzle for the next generation of engineers to solve. Thanks for watching.